Okay, this is Mrs. Black again. As you can see here, we have a 100-gram block A on top of a 50-gram block or box B on top of a floor. Alright, so I want you to draw a force vector diagram for A and a force vector diagram for B. And I need you to show the action-reaction pairs. Alright, so the action-reaction pairs are always the same type and same size, 180 degrees away from each other, because they are each half of the same interaction. So this is a single interaction, this, then this, or this, then this. Now you always draw them on two different diagrams because it takes two objects for an interaction, not one object. One object cannot interact with itself. So when you're drawing the action-reaction pairs, otherwise known as Newton's third law pairs, you're always going to draw them on two different force vector diagrams. Okay, so I created them both the same color, orange, so that you could see, and I duplicated them so you can see that they are the exact same size. They are also the same type. They're both squish squish normal forces. The only difference is this one is on A from B, and this is on B from A. So that's the only difference. Okay, so here's the normal force on A from B, and the other interaction that A has is long-range mass-mass with the Earth. So here's the gravitational force on A from the Earth, the purple one. Now because it's 100 grams and B is only 50 grams, that means the mass-mass interaction that B has here is going to be about half the size of the one A has, because gravitational force is directly proportional to mass. Now, it flips 180 degrees for B, so here's the normal force on B from A, downward, and then also downward would be the gravitational force on B from the Earth, and then upward we have this huge normal force on B from the floor. Now the normal force is much bigger than the gravitational force, the reason being that box B is getting pushed down with this normal force, part of the action-reaction pair, into the floor, so the floor is getting squished. Basically the entire weight of A and the entire weight of B. So therefore the normal force on B is going to be much larger than these action-reaction pairs, and way larger than the weight of B.